this triangle. First of all, it's good to know because I'm not telling you what to use. So we need to know what do I need to use. So the first thing I'm going to notice, what kind of triangle is it? Angle, angle, side, right? Now, so that pretty much means I know all three angles and one side, right? So angle, side, angle, you could really call it any of those cases. That is a case where I know everything I need to know. And I can use whatever law works best for me. Now, which two cases are the two cases that I have to use the law of cosines?
All sides.
Side, angle, side. So side, side, and side, angle, side. Those are the two cases we will have to use the law of cosines. What's the case where we need to be careful? True. Even worse than that. The one that causes that whole day we had to learn about.
Angle, side, side.
Angle, side, side, right? Remember, that's the bad one. You giggled a lot in geometry when you thought about it. I know. That's the one. Okay? So that's the one you have to be careful about. This is none of those cases, so this is what I would consider an easy law of sines problem. But it's nice to walk through those thoughts in your head. If it's angle, side, side, you've got to check to see how many triangles there are, right? So be careful about that if it's angle, side, side. If it's side, angle, side, or side, 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 we're going to have to use law of cosines. Anything else, any of the other cases, we're going to use law of sines, and it won't be too horrible. The angles I have are, really, I have all three angles. Why do I say I have all three angles? Yeah, if I have two angles, I can add those two together and subtract from my angle. It doesn't matter how I draw this triangle because it's not a complex triangle. Find the third angle, and what do you get for the third angle? 97 what? 0.567? Since they gave it to me in degrees minutes, just for fun, let's answer in degrees minutes. How do you get your calculator to do that? Second apps DMS, and it's 97 degrees. What'd you say? 34 minutes. Okay, any questions about that one? And then I want to find these sides. I'll use the law of sines to do that. For sides, do I have to worry about obtuse or not obtuse or anything else? The only time I have to worry about that is what? When I'm doing an inverse, finding an angle, and be careful, don't do an obtuse angle with sine inverse. It won't give you an obtuse angle. Does that make sense?
She get into that.
Second apps. See the arrow to DMS? That will convert to degrees minutes. So, quick review for the final, right? Now you know how to convert. You've forgotten how to do it by hand. Your calculator does it for you, so. The school called. I haven't checked it, so I don't know. It's not important. If it was important, we would have heard about it very shortly. It's probably another school. Somebody should get another school. So let's not be nosy. Okay, so we already have A 268.7 over the sine of 39 degrees, 54 minutes equals B over the sine of, I can't even read what, 42 degrees, 32 minutes. And so what did we get for side B? 131. 81. Any questions about that? Yes. Okay.
Answer it.
No, say that.
This one's from Texas.
They should be put away. You shouldn't be hearing your cell phones go off anyway. Okay. They are becoming a pretty big distraction. I promise you, it's just school needed to tell us something, there is an inner right there. You would be the first to know.
I don't know.
Brad took over the calling system. Okay, sine of, and I'm doing C, so 97 degrees, 34 minutes. What is side C? 400 what?
23 is what I got. Oh, it's points. Alright, not calculating.
I got 415 just here.
Okay, any questions about that one? 400 what? Let me see your calculator.
Barbara, right?
Try it again. See if you still get it. Okay, area of a triangle. Now, what is the only area of a triangle formula you know?
Divided by 2.
1/2 base times height. Everyone agree?
Yeah.
Okay, that's the only formula for the area of a triangle that you know. However, how many times are you on a problem, and you've even seen this on the ACT, that they don't give you the height of the triangle, right? So that becomes a problem. Now, of course, there are other ways to work it besides knowing the formula, and that's kind of where the formula comes from, or the other ways to work it. If you knew angle A and side AC, or example side B, right?
Yes.
Could you find a height?
Yes.
Right, sine of the angle times the base times the B would give you the height, right? And so that's where the formula comes into play. So the height is sine of A times B, right?
But you don't have B, do you?
It depends on the problem. What would that formula become if I had A and side B? Well, it would become 1/2 B times B sine of A.
Yeah.
1/2 base. And what is the base actually in this picture? Side C, right? So 1/2 CB sine of A would give you the area of that triangle. Could I have done that same thing with a different side angle combination?
Yeah, probably.
Probably 1/2 AB sine of C would give me the same thing, or any of those combinations. And this is, I can always solve for a different angle. So this is another formula for area. The good thing about this formula for area is I don't need the height of the triangle. Sorry.
Which you're finding the height.
That's area, sorry. So you're finding the height mixed in the equation. This is a formula for the area of a triangle when you have side angle side. So now, again, this is not something you couldn't create. You could find the height of the triangle every time using trig functions, and you could work it that way, but this is a little faster. So 1/2 AB sine C, 1/2 AC sine B, 1/2 BC sine of A. Those really are all the same formula, but they give you the area of a triangle in side angle side format. There is one ACT problem that I have seen ever that you had to use one of these formulas. I didn't tell you had to use one of these formulas, but it showed up. So, interesting note that it has shown up once.
You want to start?
Now, one of them would probably suffice. Does everyone know what I mean by one of them would probably? Okay. They're all the same formula, just rearranged letters.
Oh, yeah.
So one of them would probably get you the gist. So we're doing two sides and the included angle. 1/2 the two included side, the two sides given an included angle and a side angle side triangle. So this is a formula for finding the area when you aren't given the height. So how does it work? So I gave you the why it works. Here's the how it works. The area of this triangle go, I could try to find the height of it. It would be, I'd have to draw something like this to help me do that right. So it would be a little complex, a little bit more work than I'd like to do, or I could just use the formula. Doesn't matter which formula you pick because they use D, E, and F instead of A, B, and C anyway. But it's the two sides that are not the side of the angle. That's why side, angle, side. That's why this works with side, angle, side. So 1/2 9 times 12 side of 127 degrees. That will give you that area of that.
We have to know these.
This formula, yes. 43.126. If you didn't get this units, you'll get it. So what are my units?
Feet squared.
Good. And why is it feet squared? Area is square units. You didn't get that? Oh, this is the answer. Check it, make sure. Make sure he's not watching. Thank you very much. This one is not set up for that formula. Not at first glance. Why not? I have two angles. I only have one side, right? So find another side, right? Either of the other sides, it wouldn't matter, but if I found another side, that would get me enough information to use the new formula. I still don't have the height. Now, if I had the height, forget all of this and do 1/2 base times height, right? So don't forget to think, but I don't have the height. It's probably just as easy for me to find another side as it is to find the height, and then I can use 1/2 AB side of C, or something like that. I currently don't have a side angle combination to use the law of sines to find the other side. So what do? Find it. All right, find the other angle.
Oh, yeah.
Yep. And what is the other angle?
48 degrees, 20 minutes.
48 degrees, 20 minutes. And so then I can use the law of sines to find another side. It doesn't really matter which other side I find. I can work with it anyway. Does that make sense? I just need one more side. Which one do you want to find? Okay, so the one across from the 58. So B over the sine of 58 degrees 10 minutes equals 32.5 over the sine of 48 degrees 20 minutes. Multiply by the sine of 58 degrees 10 minutes. What do I get for side B? 36.962. Now, keep that number in your calculator. Don't just use the 36.962. Does everyone know what I mean by that?
I didn't finish it.
Okay. When I use this, I'm going to need to use the whole number. Okay, what I mean by that? Store that in your calculator or just keep it handy. You can go back up and grab it. So now I do know side B. So what is my formula that I'm going to use?
36.962.
1/2 side A times side B, right? Because those are the two sides I have. If I use side A and side B, what angle do I have to use in the formula?
73.30.
Sine of angle C. Good, and that's 73.30. So I just wanted to show you what I mean by the, you have to use the angle, not one of the two sides. Third side. Does that make sense? Am I going too fast? So 1/2 A is 32.5, which is what Drew was reading off. Side B, I'm just going to leave that as the letter B. Use the number from your calculator. Sine of angle C, which is 73.30. And what do you get when you type that in the calculator?
575.858 centimeters cubed.
Oh, yes, squared.
Squared.
Come on. Any questions about that one? Okay, there's one more formula for area. This one is not as common, I don't think, but you have to know for this test. I've never seen this one on an ACT problem where I have seen the other one. Again, only once, but I've seen it once. If a triangle has side lengths A, B, and C with semi-perimeter, okay, let's break down what in the world that means. What's the word semi mean?
Halfway.
Half up, and what's perimeter? All the way around. So the semi-perimeter is just the outside added up divided by 2. So all the numbers. So when is this formula useful? When you have side, side, side. I don't need any angles. So if I have 3 sides of the triangle, I can find the area just with the 3 sides. I don't need to be tight. So that's how the formula is set up to help you. And so the area is the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C, all in the square root. Multiply all those together, and that is the area of the triangle. I do have a proof of this formula. I did the proof of the other one. Hold on, let me make sure y'all have. If you don't have time to write it. Anytime I show you a formula, I'd like you to know where, like, to see where it came from. So I usually try to show you the proof behind it. But no, there's not something. You don't even have to write it down if you don't want to. It's probably in your textbook. So, using the area formula that we used on the last slide, 1/2 BC sine A, if I square both sides of that formula, I would get 1/4 B squared C squared sine squared of A. And as you know from identities, we could rewrite sine squared of A as 1 minus cosine squared of A. And then get A back by itself, you have to take the square root. That is a difference of perfect squares, so I can break that up into 1/2 BC times 1 plus cosine of A, 1/2 BC, 1 minus cosine of A. With the law of cosines, so there's quite a bit going here. I know that cosine of A is negative A squared plus B squared plus C squared divided by 2BC, so solving the law of cosines for cosine of A. If you rewrite each factor for cosine of A under those radicals, well, let's finish that. get, the BC is going to cancel, so you would get 1/2 a squared, let's see, 1/4. What happened to the rest of my proof? Cosine of A is negative A squared plus B squared plus C squared. Over 2B. So far, so good. Does everyone see how where that comes from? Times 1/2 BC 1 minus, sorry, A squared plus B squared plus C squared over 2BC. And you would have to get a common denominator and subtract. I think just for time, I'm going to spare you me working that out, but if you continue to work that out with common denominators and you do the subtraction, you end up, now that everywhere you see an S, it would actually be 1/2 of A plus B plus C. So it's really long, nasty formula, but that's where this formula comes from. Now, here's how you use it. This is the important part of it. Distance as the crow flies from Chicago to St. Louis is 262 miles. St. Louis to New Orleans is 599 miles. And New Orleans to Chicago is 834 miles. What is the area of the triangular region having these three cities as vertices? So if I were to do this using a regular triangle formula, the problem would be I don't have a height. The problem with the first formula I learned today is I don't have an angle, but I do have 3 sides, so I can use what's called Heron's formula. That last formula is called Heron's formula. What's the first thing I need to know to use the formula? The semi-perimeter, which is just 1/2 of the perimeter. Add all 3 sides up and divide it by 2. What number is that? Say that again. 847.5. Any questions about where you got that number? And then I'm going to use this formula. It is a pretty easy formula to memorize. Semi-perimeter minus A, minus B, minus C, all in a square root. It does not matter what order you do that in. So the area equals the semi-perimeter times the semi-perimeter minus side A. They didn't label it, so does it matter which one I put here? No. As long as I do one of each. 847.5 minus 599 and 847.5 minus 262. Type that in your calculator, push enter, and what do we get? 48,800.
No, 40,000. 0.302.
Yes. Still rough? That's good.
Yeah.
Okay. Miles squared. So square miles. Okay, any questions about that? So, this is your homework. It's using those 2 area formulas.
Dude.
I mean, those area formulas.